Doing? Welcome back to the Routing Loop. It's November 14. We're getting close to reInvent. Jamie and I took a break on working on reInvent slides to come jump on and stream with you folks today. Today, we're actually going to be talking about network cost optimization. We've got Dave here. Dave, do you want to give us a bit of an intro? Who are you? Where are you from? Tell us a little bit about yourself, and then we'll get into network cost optimization. This is actually a pretty important topic when we talk to a lot of large enterprises where, the slightest change in their network architecture could have grave implications on costs. So I'm actually super excited to dive into this one.
Yeah, thanks, Matt. So my name's Dave DeRicco. So I'm actually part of our enterprise support team. So I'm a networking specialist TAM. So if you have enterprise support, you probably have a TAM that you've worked with or interacted with at some point. And so I'm the networking specialist version of that. So part of enterprise support team, covering a lot of similar ground, but again, generally focused on like larger enterprise customers. But the concept of cost optimization kind of goes across the board. So there'll be a lot of things in here today, hopefully, that whether you are a large enterprise or maybe you're smaller, depending on whatever size you are, there'll be something here that like makes sense for you in terms of like network cost optimization.
Yeah, I was going to make a comment too. It's not just enterprises, right? Sometimes folks want to be on and be as scrappy as they possibly can, get their proof of concept and ready to go, and then start looking at what does the next step look like, and then the next cost, and then what does the enterprise step look like in the next cost. So I think in these day and age, and you guys, of course, correct me if I'm wrong, but cost is almost always on the top of everyone's mind right around now.
Mm-hmm. Yeah, absolutely. It's different too, especially for like networking teams. Like if you think about, if you are more familiar with like on-prem networking, right? So you think about, you buy these large devices, you put them into a rack somewhere, you cable them up, you connect them, and then they're ready. They're there, but they're ready. But it doesn't really matter like how much data you pass through them, right? So as long as it, is within the capacity of the device, you're sending the data through, the device can handle it. That's all you really care about. But in the cloud, it's different. As with all things in AWS, what you consume is what you pay. That's the cost there. It's based off of how you're using that. So that can also be a little bit of a mind shift, especially, I see this a lot with customers maybe who are starting off, they've come from like a traditional on-prem network and maybe they've just done a lift and shift into the cloud, or they're just getting started in the cloud and they're, understand the concepts from before, but they haven't really like implemented this in the cloud. So it goes across the entire spectrum. Absolutely.
So what would you say, just gonna ask one question before you get into the meat, but like if we are going to start in our journey with networking, or if we're going to do a large project, or we're already in the cloud, or we're going to move to the cloud, what would you say are the number one things that folks should be thinking about when they start to tackle cost optimization for networking? Versus like say compute. So like for instance, compute, you may have a application or a program, what it's going to burn, what it's going to eat on the machine, possibly how many hours, how long it's going to be up, right? You got container scheduling and all that. But when you have these external factors, like folks from the internet coming in, or maybe a runaway process, like what's your thought process on tackling some of those issues?
So monitoring is always going to be number one thing that you need to do, especially if you're dealing with sort of these unknown variables, right? Because if you are launching something for the first time, you don't know how many users you're going to have, or you don't have a sense of what the scale is going to look like when it's actually live. Monitoring that and having the understanding of like, okay, this is a threshold and we're planning for costs up to here. If it goes beyond that, maybe that constitutes an architecture change. Or maybe you need to think about like, okay, this is where we are for the first 30 days. As we scale up, we're going to plan to go to this separate architecture. And I'll talk about that a little bit later too, where as you are scaling things up, or depending on how things are moving for you, you might need to make changes because it makes more sense to do so. So monitoring, definitely. And there's just some stuff that's like basic. I would even call them like table stakes at this point, like using certain types of like interface endpoints or gateway endpoints in a VPC. If you're using S3 or DynamoDB, we'll talk about that a little bit more, but that's like easy stuff, like stuff that you could just like almost do by default and not even have to think about it as a best practice and just reap the benefits of those.
I think one thing I want to call out, and story time now from Matt, is back in the day we used to have someone who would buy big hunkin routers and hardware, and it would get put in a data center, and then they'd hand it over to me, or I would put it in a data center and install it. And then we play around with it. We install it, it goes into production, and it's being used. I never saw any dollars. It just never even occurred to us, because someone in procurement would buy equipment based on our recommendations. This is probably the second week I was in AWS. I went in and spun up an RDS cluster, and my internal account that month had a $10,000 bill. And there was no recourse, because obviously I work for AWS, but if I had worked for another company, they'd be like, hey, question marks, what's going on here? Right. So I think the times have shifted a little bit, where you both see the effect, but you also have the levers to control. And so I think what we're going to talk about here are some of the levers that you can control within your environment to really make sure you're doing the right things from a cost perspective. I think it's a different world now than what we used to see, right?
For sure.
And here's our first question for you, Dave. Dominic, good friend, a longtime friend of the show, says, do you think we have enough metrics in CloudWatch right now to actually measure our networking costs?
The metrics that you're typically going to use for that are going to be around like data bytes, right? So the amount of data that's going through. So like with an ELB, for example, or a transit gateway bytes, like that type of thing. Those are the kinds of things where you can take those and then apply them to cost. There's kind of two directions that you could approach this from. You can either approach it from the metrics direction, which would be something like going to the actual resources, looking at the metrics, and then like extrapolating from there, based off of whatever the pricing calculator tells you. Or you can come out from the other direction, where you're looking at maybe like a cost and usage report, or you're looking at something like Cost Explorer, and you're drilling down into individual accounts and seeing like, okay, in this particular account or this particular subset of accounts, I can go and get my costs from there. Are there gaps in CloudWatch in terms of the metrics? Potentially. None come to mind right now, but that can be one of those challenges. And usually it's not so much around not having the metric be available. It's more of a question of like, you just don't even know what it is until you turn it on and then see what starts flowing through it. Like that kind of guesstimation or, foretelling of the future can be really challenging.
Now, you mentioned a cost and usage report, which we've also used to lovingly refer to when I was a journalist essay as a CUR. Can you explain what that is? Because not everybody has enterprise support, so they may not know what that means.
Yeah, so essentially a cost and usage report is like you can think of it as like a very detailed breakdown of every cost that is incurred as part of your AWS environment. So you set up a cost and usage report. Typically, you're doing that at the org level. And then from there, it gives you like a very highly detailed breakdown, like a very granular breakdown of what the service usage was. So, let's use something like a transit gateway. Transit gateway has attachment costs. So you would see the transit gateway cost, you'd see the attachment there, you'd see if there was any kind of, discounts or billing, even for certain things that don't necessarily have a cost associated with them, but are still monitored as a line item, you would see those there as well. So it's very detailed and it's a very granular data source. But the nice thing about it is, you can do SQL queries against it. So if you use something like Amazon Athena, you know SQL, which to me is like, knowing a foreign language and witchcraft. And I don't mess with SQL, so like that scares me. But we do have pretty dashboards. So there's a number of tools that you can use to create dashboards off of that, which I like, because then I can actually look at it instead of trying to, select this from that. And I don't know, but that doesn't make sense to me. But there are a lot of like great tools out there, and I think we have some. I could probably pull them up later if that's something that you all were interested in to see more about that.
I have a really bad habit of, if I get access to a database, I do select star and export it to Excel. People don't like that.
You put it in a flat file and use VI.
You might melt something, Matt. Like that's just going to be flames everywhere. I'm
like, who else uses this database? Is this critical? Because I want to take everything and put it into Excel right now. How many rows are there?
The very first time they gave me access when I joined the service teams to the BD database, I almost crashed it because of the queries I was doing. It's like, okay, grab all these elements and put them all together and give me this awesome result. And they're like, Jamie, what did you do? Oh, wow.
When you don't get a response, you're like, should I call someone right now?
Yeah, no, it didn't. That didn't even happen. I just immediately got like a little Slack pop up and like, excuse me, because it was my user, right? What are you doing? What are they doing letting a networking person touch a database? I mean, that's what I want to know.
I mean, that's how I feel whenever I would have to interact with CUR. And this was even before I was a networking specialist. So I don't know. It's not my thing, but that's okay.
So as a network specialist, how would someone like the three of us here jump into our account and have a look at our code or glean some useful data back from it? I don't know if I'm jumping the gun here and you're going to dive into that, but
no, I'm not going to dive into that specifically. So typically, and again, it's going to depend on how your environment is set up. A lot of times with a lot of customers that I've worked with, the cost and usage report is something that's like implemented at sort of like an organizational level, right? So that might be like something that's visible at the payer account. And then from there might be dashboards that are then visible for, individual teams to consume based off of, how those dashboards have been configured. So I don't know, it's, if your organization, again, depending if you have a cost and usage report set up, you might not have immediate access to it. Most of the time, though, if you have access to the console, you can also use Cost Explorer, which, is maybe a little less granular, but does give you a lot of good insights and trends, and like can usually get you started towards identifying a lot of, if you've seen an increase in costs and someone's coming and chasing after you saying like, hey, why are your costs so high? That's a good place for you to start, and you can kind of like track it down from there. And again, usually that's if you have console access, you can get Cost Explorer.
I'm going to look at my Cost Explorer on my internal account right now.
I'm afraid to.
See what's going on.
All right. So do you want to dig in? You have something you want to start off and show us?
Yeah.
Okay.
So I've got some slides, but we are obviously not beholden to them. So, as questions come up, as people are asking things, like definitely, make sure you're throwing the questions in the chat there. I'm happy to skip around. If this is boring, you can also just be like, boo, no more slides, and we can whiteboard or something else. Like, it's totally fine.
Hey, real talk though. I'm looking at my Cost Explorer right now, and I don't know if I can share this one, but I just realized that I'm paying like $400 a month for Certificate Manager for something that I no longer need. So you just saved me $400 a month. Oh, Amazon.
Yeah, there you go.
All right, great. That's it.
There we go. So
Job
that's
done.
the end of the show. And
thank you very much.
Shut it down. We're done here.
Yeah.
All right, cool. So yeah, I'm gonna go through this. Like I said, if there are questions, folks in the chat, don't hesitate to talk about it. So what we're going to talk about today is when we think about networking costs in AWS, there's really three types of networking service costs. I'm going to just kind of go through those. If you've listened to the routing loop before, if you've been part of the show before, you'll probably recognize a lot of these. But if not, hopefully this will be something new for you. I'll give you some common culprits, some common like drivers of network costs that I've seen in my conversations with customers. Now, this is certainly not going to be a comprehensive list by any stretch, certificate managers notwithstanding, but this will be some of the ones that I see most frequently when I'm talking to customers that I work with. So from there, we also have a solution that's called a networking cost calculator. It launched in a blog post, I want to say it was about a month ago now, maybe a month and a half. We can take a quick look at that as well. Again, just kind of break things up a little bit. We'll talk about some network cost optimization examples, kind of bring it back all together at the end, give you some additional resources, additional like blog posts and things that you can look at if that's something you want to do. If not, we can also look at them here. All right, so to talk about networking service costs. Yes, thank you for sharing the link, whoever just did that. Awesome. So when we talk about networking costs, it breaks down into three different types. So the first is going to be data transfer charges, right? And you can think of that basically as how much data crosses a boundary. Now, when I'm saying a boundary, I'm talking about things like, so here, like a boundary could be a region. So you're crossing out of one region into another. It could be crossing out of an availability zone into another. You're crossing that AZ boundary there. It could also be going out to the internet, where you are crossing the boundary out of AWS to the internet. That's where data transfer comes in when you are crossing a boundary. Second type is going to be service usage charges. Now, this is pretty straightforward. It's just how long is a service running? You create a service, it exists, it's there, it's ready to accept packets, it's ready to load balance, it's ready to NAT, it's ready to do whatever. It's ready to do that. As long as it is sitting there, there is a cost associated with that. And then the last one, which is usually where a lot of folks start to, bang their knee maybe a little bit, are on the data processing costs. And that is just how much data passes through a service. So if you have a networking service, again, this could be like a NAT gateway is a very common example, or or a transit gateway or a cloud and core network, any of those components, you send data through those, there's data processing costs associated with that. And that's basically the breakdown of the 3 different costs that are, when we talk about networking costs, that's what you would expect to see there. Let me talk about data transfer boundaries a little bit more. And again, make sure you're asking questions if something seems weird or doesn't make sense. So the internet, I mentioned this already, where if you have the cloud, we have the internet, we want to send data out to the internet. There's a cost associated with that. So we mentioned already like cost and usage report and cost explorer. So I'm actually glad we did, because if you're looking to understand a little bit more about like how much that's costing you, you can look at the data transfer out bytes, and that'll tell you how much data is, again, crossing that boundary out from the cloud to the internet. And you typically will have the region associated with it as well, like, US East 2, EU West 1, whatever you are doing there. Then we have traffic coming back in. So if traffic coming back in, there's no cost associated with that. Pretty straightforward. Data in is free. Data out, there's a cost there.
I think there's something that makes a lot of sense to folks that have worked in the internet world around transit and peering arrangements between service providers. And so folks are wondering, why is it free in and cost money coming out? Is that us trying to keep data in AWS? It's not at all. We actually pay money for data to transit through someone's network. And so when you send a packet from AWS, it's going through someone else's network, and we have to pay dollars. If network or packets are coming back in, they're paying us. And so hopefully there's about a 50-50 break in traffic there, and we have a peering arrangement, which is generally the case. Sometimes providers have to pay money to send traffic to another network like us in some cases. So that's basically why you see this disparity between us charging dollars for traffic going out and data coming in that's being free.
That's a good explanation. That's actually the first time I've ever heard that. So thanks, Matt.
I think when you work in the internet service provider realm, you work with other parties, and basically you have, imagine 2 routers in a data center that plug into each other, and they basically say, hey, who's going to pay for this connection, right? If you're sending me more packets, then it's at a disadvantage to me, so you should pay. If I'm sending you more packets, then maybe I should pay. And so that's really what breaks down how a internet transit or peering arrangement is made. So we have many, many, many different peering arrangements. Maybe good idea for a future session, Jamie. We should bring in someone like Tom Scholl to talk about what our internet peering arrangements look like. And I mean, it's super, super fascinating stuff. But anyway, distraction.
It also changed the way that we do routing protocols, if you remember, on the internet, because you need something a lot less chatty, so you wouldn't get that much extra traffic back and forth as well. Yeah, it is a very awesome topic. Back in my data center days when I was doing stuff like that too. Anyway, go ahead, Dave.
Let's keep going.
No, this is good. I like this. Let me know when that session's on. I want to make sure dial into that one too. All right. Yeah. So boundaries, regions. Already mentioned that before. This is pretty common. Again, if you're sending data across region, you've got 2 regions here, region 1, region 2. If you're sending data out, you're crossing a regional boundary. So again, when you cross a boundary, you need to think about whether there's going to be a cost incurred there. So for that, you're going to see, again, whether that's in a cost and usage report or in Cost Explorer, you're going to see that source region, destination region, and it's going to be, show up as AWS out bytes, and there will be a cost associated with that. Now, you're crossing a boundary into region 2. There is no cost associated with that. It's just the region out to the region in. You'll still see the line item there, like if you're looking at it in a report or something like that, but there's not going to be a cost associated with it. It'll just be zeroed out, but it will tell you how much in terms of like, bytes is actually passing in to give you a sense of like, yeah, this is out, this is in, just to balance things out a little bit. And then last but certainly not least is, and this is probably the most common one that I see with folks, not expecting things, is availability zones. So within a region, you've got 2 AZs, more AZs than that, but for the sake of the example, we'll just use 2 here. And we're sending data out. We're crossing that boundary of an availability zone. So we're going out. There's a cost associated with that. And we're going in, and there is a cost associated with that as well. Now, a lot of times we're going to you'll hear people kind of talk about this and kind of lump these 2 together, but it really is like an out and an in that's associated with the AZ, cross AZ data transfer. And this will be referred to as like cross AZ, inter AZ, Inter-AZ, intra-region. Like I always mix up inter and intra, so I really have to like stop and like put the brakes in my brain and be like, wait, which one's which again? Suffice to say, it's from one AZ to another. Whatever you want to call it, that's what that looks like.
I'm not sure what our external codes are, but internally we normally refer to them as DTAZ, data transfer AZ, or DTIR, data transfer inter-region. We don't use the intra-region stuff, although I use that all the time. Like that's how I talk about traffic that stays inside a region. I'll say, hey, it's intra-region. I think what's interesting here, and I don't know if you're going to dive into this, is if we were to use peering, for example, to connect from one region to another, or peering to connect between two VPCs in the same region across availability zones or inside a single AZ, versus if there was something like a transit gateway where there's a fleet involved and there's packet processing and some other considerations there. We can get into that now, or I don't know if you've got some other content.
Yeah, so we will come to that, because like VPC to VPC traffic is one of like the top 4 or 5 like things that I most commonly see. Or like drivers of cost where customers are thinking about it. So peering is something that definitely, again, don't want to spoil my own thunder here, but is something that I think people sleep on a little bit and is worth thinking about a little bit more, whether you're doing like a cross-region setup. And I've got an example later on too, where a customer was doing something wild and it turned out that they didn't need to do any of that and they could just use peering. So
okay, let's keep going.
Peering is not dead, guys. That's the
It's not. That's what I'm saying. Like I think people need to remember that it's still an option, right? You can do all of these things. It's not just transit gateway or it's just cloud WAN. Like you can use that with peering as well. And there are plenty of great examples where that makes sense to do it.
I always like
a hammer to paint the fence.
You're going to use tools as well. I was going to say, in my toolbox, I've got some Phillips head screwdrivers, and I've also got a nice electric drill. I still use the screwdrivers to work on stuff. I'm not going to always use the drill for everything, right?
The drill can strip out certain screws, right?
There you go.
There you go.
Well, then you got to use maybe a different bit or different screws, different heads. Like how far down this rabbit hole you want to go, Jamie?
Yeah. How much torque is on the electric one versus how much human torque?
Yeah. Wait, was Transit Gateway the drill? Or
yeah, Transit Gateway I think would be the drill. It's actually funny when you work on engines, when you're using torque wrenches and stuff, it's always better to not use impact or anything. But you also have to be careful of the fact that you can strip screws so much easier with the more leverage you have. Anyway, that's another rabbit hole.
I like it. Cool. So just to kind of illustrate the data transfer charges, I've got as an example architecture here. I'm waving at my screen. You're actually seeing it there. So I don't know. I'm not going to worry about my hands too much.
If you want to move your sharing button there just to the right, it looks like you've got data transfer and then a line through charges.
Okay. Yeah. Give me 1 second. So, thanks, Matt.
Yeah. Just move it over there or something. Yeah. Perfect.
Perfect. Is that better?
Yep. Much better.
Great. Cool. So I'm going to use some real world pricing examples. Anytime pricing comes up, use the pricing calculator. Like this is accurate as of to the time when I did it. But that also means that there could be changes. So if you're ever in doubt, always use the pricing calculator. Don't rely on someone who has very good intentions and has had this checked, but maybe there's something a little inaccurate about it. Make sure that you're always using the pricing calculator. All right, so we've got an example here. So we've got a VPC. It's got 2 separate AZs. We've got a NAT gateway in each AZ. We've got gateway load balancer endpoints in each one. For the record, behind those gateway load balancer endpoints, you would have an inspection VPC that has, a gateway load balancer itself that would have some virtual appliances there. I'm not showing those here because I don't want to complicate the diagram. I will show those more later. So if we want to dig into that, we certainly can. But I'm keeping it high level here just for the sake of illustrating like how this will all fit together. So let's say we're doing something where we want to send traffic between these AZs. So let's say we have 100 gig of data. We're sending data out. Remember, we're crossing the AZ boundary. So there's a cost associated with that out. And then we're crossing the AZ boundary back in. So there's a cost associated with that as well. That's data transfer charges. And that's just within the same VPC. We're staying within the same region, but we're crossing availability zones. Now we do something like we want to go out to the internet. From a data transfer cost perspective, the only time you're going to incur those costs is when you're crossing that boundary out of the region to the internet from a data transfer perspective, because you're crossing that boundary out from AWS out to the internet. So again, remember, think about the data transfer charges in terms of those boundaries there. And so in that case, that comes out to around $9 if you're doing 100 gigabytes of data at 9 cents per gigabyte of internet data transfer out, or DTO, as we refer to it pretty frequently. Now, the other thing is, let's say we do something like this, where we had an instance here and we didn't have a NAT gateway or a gateway load balancer endpoint, but we still wanted to send traffic out to the internet, right? So in that case, we would incur the additional data transfer charges because now we're crossing AZs to go to like our gateway load balancer endpoint and then to our NAT gateway. We're doing out, we're doing in, and then we're still incurring the internet data transfer out. Now you could do this, but if you have done this at all, or if you've worked at all with AWS, you're probably thinking that there's something wrong with this. Does anyone want to take a stab at what this is? Maybe folks in the chat.
This is where we cue the Jeopardy music.
I'm looking at you, Dominic, because you were just asking about NAT gateway costs.
Yeah, exactly.
All right, so Dominic, if you what's wrong with this picture?
We really do need some Jeopardy music.
I know that'll be on my notes for next time. So to not belabor the point too much, what we've done now is we've potentially done two things. So we've potentially saved a little bit on not having a NAT gateway, an additional NAT gateway, and an additional gateway load balancer endpoint, which we'll talk about momentarily. But now we're adding cross AZ charges, and we've also created an availability risk for ourselves, right? So now if something happens where, I don't know if I do this here. Yeah, my slides aren't that fancy, but if you imagine that AZA just goes away, or maybe there's a failure, somewhere in AZA, now that instance that's in AZB can't talk to the internet. It's just completely cut off. And you've also incurred those additional costs there. So if you take nothing else away from this cost optimization discussion, it's that network cost optimization doesn't exist in a void. When you make changes like this, you need to think about what are the implications of that from an availability perspective, security perspective. There's a lot of other things that kind of come into it here. So on paper, this might save you a little money depending on how much data you're sending. But in practice, this is also now opening you up to other risks that might have a different cost that you just haven't really quantified in that way.
I just want to point out one thing too that you had mentioned, which is pretty funny, that when you start looking at everything in terms of cost, and as well as when you're looking at things in terms of availability, a lot of times the always example would be, what if AZA goes away? But what I've seen a lot working with customers, and I know you've seen this too as well, Matt, is that it usually comes down to, what if somebody on your team makes a human error and you can no longer route to anything on the subnet that you have on AZA, right? And it takes everything out. So not to drink the AWS Kool-Aid so much, saying AZA will never go out. And of course, I'm knocking on wood that it never would. But the reality is most of the mistakes that are typically made are made during adds, moves, and changes. And, just like when you were helping me preview some of my slides, Dave, and you pointed out, hey, you have a spelling error here, and I've been working on it so long, and I know how to spell, but there are some things that are just so easily missed that you could take out your own AZs without ever realizing it. And then you will now pay for the costs that you're showing here.
Yep.
I think that there's also this question mark of, and this was maybe when NAT Gateway first came out, people were trying to build to avoid failures, and we'd say, hey, a single EC2 instance can go away all the time. And a NAT instance looks very similar to a NAT gateway in the way that it's presented inside an availability zone, but they're actually two vastly different things. And so I think one of the shifts that we've been working on for the last, 5, 6, 7 years to try and help customers build in this way is the NAT gateway is actually a fleet. And what you're doing here is, in this idea, you're sending traffic to a secondary NAT gateway, maybe in case the first fails, or maybe you've just configured it this way. But really, you should try and pin things inside the same AZ. And so you've got your instance to a gateway load balancer, which represents a fleet inside that same AZ. So you've got redundancy through the fleet itself, then a NAT gateway, which has another fleet, redundancy through that, then connected to the internet gateway, which is a region-wide deployment that is a fleet as well, right? So you're not actually gaining anything by trying to send traffic to another availability zone here. And if one AZ fails, your instances in that fail in that AZ fail anyway, right? So I think maybe it's your next slide, but having that instance talk all the way through the inspection VPC and the public subnet inside that same AZ is absolutely the better way to go.
Absolutely. Yeah. Like this here, if you're watching this, don't do this. This is a bad idea. Like, don't do this. I'm using this to just illustrate the point, and also, again, reiterate that you can make decisions that are just based off of cost, but you don't want cost to be the only factor that outweighs everything, because you're going to get into situations like this, which you don't want to do.
But it's only an extra $2 a 100 gigabyte.
Was that penny wise, pound foolish? Isn't that the statement?
Yes. Yes, it is.
Okay.
So all right,
Nice.
so let's make things good. Let's fix this. Let's get away from that really bad idea. So we talked about our other costs there. So let's talk about our service usage hourly costs. So we've got NAT gateway. So Dominic, I think this is where you were jumping in. So first thing we're going to deal with is NAT gateway has an hourly cost there. So in US East 1 for this particular example, it's 4.5 cents per hour. Gateway load balancer endpoints. Again, I'm not showing the gateway load balancer and the inspection VPC. Assume that they're there, but for the sake of this diagram, this illustration, I'm not going to show them. As 1 cent per hour. And the other thing that you need to keep in mind too is that there's this cost for public IPv4 addresses. Now, this is not something that's new. Well, I guess it's like new within the last year and a half, right? Beginning of 2023. But it is something worth keeping in mind as well, that is a cost that you'll incur whenever you've got a resource that has a public IPv4 address. So a NAT gateway is going to have a public IPv4 address. Therefore, we'll incur that additional cost for an IPv4 address. And these are just going to be, so we have multiple NAT gateways, we have multiple gateway load balancer endpoints. This is going to be across all of the AZs. And if we had additional AZs like AZC, AZD, et cetera, and you had those resources deployed there, you would see that as well. So, if you do the math on that, it comes out to, typically in the cost calculator, the pricing calculator, we say 730 hours is like our monthly hour estimate, because months are variable in terms of their days. And then that comes out to, excuse me, around 65 plus 14, and then you've got some additional cost for the IPv4. Yeah, so comment about using the IPAM dashboard to find unused public IPs. Yeah, you can definitely do that. There's also, like within Trusted Advisor, if you have any unused Elastic IP addresses, it'll point that out as well. So that's another way that you can identify addresses that you aren't using potentially. And last but not least, and this is probably, Dominic, what you were thinking of when you were talking about NAT gateway cost, is going to be data processing. So let's go with our flow here. So we're sending data from an EC2 instance to a gateway load balancer endpoint. That has a cost per gigabyte associated with it. It's data processing there, right? So you send data through a gateway load balancer endpoint. It goes off, it gets inspected. Again, I'm just focusing on the gateway load balancer endpoint cost, but I'll give you an example with the full flow later so you can see what that looks like. Traffic gets inspected, comes back through. Now we're sending it to our NAT gateway. The NAT gateway has a data processing cost associated with that as well. From there, it goes out through the internet gateway, and we already talked about how there's data transfer there, but this isn't service data processing. This is NAT gateway. This is the gateway load balancer endpoint. You're sending data through those services. They're doing a thing for you, whether that's they're passing it off to a gateway load balancer, it's natting the traffic. That's data processing, and there's a cost associated with that there. So if we take something like that, and again, usually it's not going to be a whole lot. So if we start with, the gateway load balancer endpoint, and we add the NAT gateway, that's what those costs roughly look like. Now, if we scale that up, so let me just go back to really illustrate the point here. So we started with 100 gigabytes of data, and that's not a whole lot in terms of cost, right? But now we're scaling that up. So if we take the same design and we approach it with 100 terabytes of data, instead we're sending that out. Now it's much higher, right? So this is another point that I kind of wanted to illustrate here, is that as you start to scale things up, you're going to see those costs increase, and that might be an opportunity for you to think about, okay, is this still the right approach? Is this still the right architecture for me to do something like this? Because a lot of times when customers that I've talked to are kind of grappling with their networking costs for the first time, it's the data processing that is unexpected and kind of surprises them and gets them, because they weren't really thinking about it. They just kept throwing more stuff at it, and then were surprised when it started to cost them additional.
So one question I would have.
Yeah.
Oh, sorry.
I was going to real quick. I was going to say I cheated here because I used a calculator, but 100 terabytes per month to gigabits per second. If we trust this freemium calculator on Google somewhere, turns out to be 310 megabits per second for the full month, which no one ever does. You have peaks and troughs. So I wonder what an average amount of bandwidth would look like, or usage would look like, if you're talking to the internet, right? Because 300 megabits per second is actually quite low when you think about how much bandwidth our instances can push the internet. I don't think we have the answer to that, but just a curiosity.
Yeah, I don't know. It's definitely a good call out. It's always hard to think about like the scale of things, when you're operating predominantly, like, so I work in like a lot of like lab environments, right? And so customers that I'm talking to, might not always be like, oh yeah, we're pushing like, however much per month. So this is mostly to illustrate the point, but Matt, you're absolutely right that the scale can just only increase or decrease from there.
I think just real quick here, 100 gig instance, which can push 50 gigabits per second to the public internet. If it was running full, as in 50 gigabits per second for the whole month, would be 16,000 terabytes for that month. So that's...
Okay, what's more expensive than the running of that EC2 instance or the data that you're pushing out?
Yeah, I don't know what those instances cost. Like a P4D, which you'd probably have to use, is like $13 an hour or something. So that's pretty pricey as well. Don't quote me on those numbers. I think it's $13 an hour.
Always use the pricing calculator.
My question was, when you're talking about people being surprised about the data processing cost versus the actual data out, is that because data processing cost doesn't have like the tiered pricing like data out would? You know how we do the after so many, your cost is X, and then so much more, your cost is even lower X, versus the processing charge, which is typically straightforward. Just wondering if like that's what you've observed when you were doing this, Dave.
I think maybe I'm not understanding what you're asking. Like, why are people surprised by it? Is that kind of
yeah? Like, is it the surprise where they're expecting the tiered costs to kick in after things go, after their traffic picks up?
In a lot of the cases I've talked to customers, now again, I'm focusing on enterprise support customers, so this might not be the case for everyone, but when I talk to customers, a lot of the time they didn't even realize how much data they were just sending out. Like, it wasn't even something that they really thought about. It was just, we've designed this application, it's built in such a way, we've met all our other requirements, and the amount of data that was being sent out was kind of an afterthought. Like, it wasn't something that they really considered as part of the design or as part of the cost implications of implementing it that way. So they
weren't even looking at tiered pricing at all. They were just like, I'm just sending the data out.
Yeah.
And oh my goodness. Kind of thing.
Yeah. Or like, a great example would be, and this was something that I ran into, where you had a development team that was, had built this application that was going to be, pumping a ton of data in and out. And they were just like, okay, well, we've plugged it into, the transit gateway, and we don't care, right? Because, we've got our default route to the transit gateway. What happens there is beyond us. Well, on the other side of that transit gateway, there's the transit gateway itself. Then they had like network firewall on top of that. And then, they were using NAT gateway with that. So, and, there's the NAT gateway and the network firewall data, processing, I don't know how you want to call it, not forgiveness exactly, but it zeroes out the NAT gateway cost, which we'll talk about later too. But they just weren't even thinking about like the downstream effect of that. Whereas the networking team was suddenly like, wait, where's all this data coming from? Like, why are we getting this here?
Right.
I think one interesting point there is we have changed the data transfer charges for things like transit gateway and cross AZ traffic over peering in recent-ish times. I think back in 2022, we changed, I think it was private link transit gateway, and I think that was it, where we used to charge data processing for transit gateway and cross AZ charges. We actually zeroed out the cross AZ charge because you're paying for the data processing, which I thought was a good change. But
they did that for the application load balancer as well. So
and ALB. Okay, great. I guess coming back to peering, where peering is king as well. If you're within the same AZ and you peer between two VPCs, you don't pay any data transfer charges. Whereas if you're using transit gateway, you would pay a data processing charge to use the transit gateway for that within the same.
Are you going to show everybody your peering tattoo, Matt?
I mean, I just don't want peering to go away. Like, I just think it's a great tool. that folks should
I
not
feel like
forget
this
about.
is a Dominic statement where he's like patting you on the back. Can't hear everything.
You can't peer everything. Come on. It's true. It's true. We do have a limit on peers. You can only have 125 peers to a single VPC, and it can get unwieldy. And I think I have a famous slide somewhere where it's an n to the n minus 1 over 2 problem, where if you have 40 VPCs that are fully meshed, I forget the numbers, but no, it was 100 VPCs fully meshed. You need 4,950 peers, which just isn't possible. So use Transit Gateway. So
let's not even talking about the routing that is needed on each of the VPCs per peer. Anyway, we're now getting into the rabbit hole again. See, Dave, this is why you only pick one of us to host your show.
I mean,
hey, there was a question from Hepta5 on V4 addresses to NAT. Do you want to talk about that for just a second?
So one IPv4 address to NAT to 9,999 IPv6 IPs. So if you had like an IPv6 only subnet or like a dual stack subnet in a VPC, because remember, you can't have an IPv6 only VPC today, right? You can do a dual stack VPC. You still have to have an IPv4 CIDR, but you can do IPv6 only subnets. What you could do is you could have all of those resources in the IPv6 subnet, but if they need to communicate to IPv4 resources, which, let's be honest, there's plenty of that still out there. Not everything talks IPv6 yet, my ISP being one of them. What you could do is you could do what's referred to as like NAT64 and DNS64, right? So if you're trying to connect to, example.com, and that's a, IPv4 only resource, but you've only got, an IPv6 subnet. If you enable DNS64, what you'll do is you'll put in it'll query for this, quad A record for this resource. One's not available, so one will be synthesized for you and it'll come back. And then you send that to the NAT gateway, and the NAT gateway is going to do that NAT64 for you and send it out via the IPv4. So that's that's functionally how you can do one IPv4 address, natting with a bunch of, IPv6 resources behind it that aren't consuming IPv4.
So even with IPv6, we're still going to have NAT. I think the next question is when are we going to support NAT 6 to 6, which, we don't talk about plans here, but
why would you want NAT 6 to 6?
That's a good question. We should ask the folks that are asking that question.
Yeah, exactly.
Yeah, not something that you can do. I think you would need to have like an appliance to do that, if I'm not mistaken, right?
Yeah, you could probably hack around with it with an IP tables rule on a NAT instance or something like that.
Probably needs like 3 addresses too, because you have to cross the boundary back and forth.
Yeah, I actually asked a rude question from Jeff Houston once, who's one of the grandfathers of the Australian internet and one of the big advocates for IPv6. Great guy. I mean, awesome, fully knowledgeable. I think he was the equivalent of the US ARPANET. I think APNIC was the Australian one. I forget. He founded the Australian internet. I said, hey, with IPv6, are we still going to need NAT? And how can we do NAT? And I thought he would, shoot me down. But he actually said, you know what? There are use cases for NAT 6 to NAT 6. I mean, when NAT isn't going to go away, but we just want to use it less. We don't want to have to be reliant on it everywhere, which is what V6 really gives us.
So Hepta5, does that answer your question? Does that make sense? I don't talk about NAT64 a lot more than kind of the overview I just gave, but we've got a bunch of like resources. Like I know we've got at least one blog post where we talk about how NAT64 and DNS64 works within a VPC. We could probably pull that up and drop it in the chat if that's something you wanted to see.
Yeah, we threw a link in there for our NAT gateway NAT64 to DNS and DNS64
right.
link as well.
Right. Cool.
All right, let's keep rolling.
Shiny. All right. So we put this all together. And again, going back to the 100 gigabyte example, when you look at this, the thing that's going to stand out here is the service usage hours, right? So this is fairly small scale. Like the service usage hourly cost is going to be the smallest thing here. And kind of what I illustrated earlier, where if you scale the amount of data that you're sending through this, now all of a sudden the service usage hourly cost isn't as big of a concern because you're sending way more data through, and you're seeing more of that from data transfer perspective as well as the service data processing perspective. So again, kind of illustrating that as you start to scale things, and depending on the volume of data you're passing through, where you're going to focus your cost opt efforts, whether that's on hourly cost versus data transfer or data processing, is going to shift a little bit. It might necessitate some different discussions there. Moral of the story that I wanted to illustrate. So, common culprits. some folks have already called out NAT gateway. We'll come to that one. I think there's a good excuse for NAT gateway, but also there's some opportunities there as well. But cross-zone load balancing, this is something that I think people turn on sometimes and without really understanding the cost implications of that. So Jamie, I think you mentioned this already, where when we talk about something like an application load balancer, right? So an ALB, you create one, it exists, it's ready to do load balancing. There's an hourly cost associated with it. It's got load balancer capacity units, which are measured on some different dimensions there. So there's the cost per gigabyte. It's based off of a number of different connections, active connections, all of that. Rule evaluations is one of them. So LCUs are kind of like the slight exception to the data processing rule, but there's generally very similar there. So it's kind of want to lump them all together. ALB is going to typically have a public IPv4 address. You can do an IPv6 only ALB now, or rather an ALB that exists without a public IPv4 address. It'll still have private IPs. And then you'll have data transfer out if you're sending data back out over that load balancer out to the internet. But if you're doing cross AZ or cross-zone load balancing, those costs are waived for the ALB. There's not a cost associated with that. For a while, it was one of those things where you couldn't turn it on or off. It was just on by default. And I think, Jamie, correct me if I'm wrong, that was something that we did change, right? Where you could turn that off. And that was part of, kind of the response to that, right?
That and also routing issues and, different types of implications outside of cost that needed to be taken care of. But yeah.
Yeah. So again, when you have this, whether you have this enabled or not, it's waived. So if you do have it turned on, you don't have to think about cross-zone load balancing. The difference with something like a network load balancer, and the same concept is going to actually apply for a gateway load balancer as well, is a lot of these costs are going to be the same. You have the hourly costs, the LCUs, the public IPv4, all that good stuff, data transfer out. But now if you have cross-zone load balancing enabled, you are going to incur a cost with that. Again, because you're crossing the AZ boundary, AZ out, AZ in. That's an additional cost there. This can come up whether you have like NLB cross-zone load balancing enabled. If you're using something like a gateway load balancer where you have firewall appliances and you maybe only have like one per AZ and you've turned on cross-zone load balancing, depending on how that flow is routed, that's going to cross the AZ boundary. That'll incur additional cost as part of those flows. So it's something to keep in mind there when you're thinking about what are some of the common culprits there. Sometimes customers they turn it on because like, oh, I need cross-zone load balancing. But they don't really think about like, do I actually want this here? Is this something that I need? Or is my architecture designed in such a way that I can just have, this notion of zonal affinity, right? Where I only want to maintain things within a single zone and I don't want to cross zones unnecessarily.
Right. Yeah. Like with an NLB, you can do like DNS affinity and things like that, because we are trying our best to keep everything. We're trying to save you money. You as the customer is what I'm trying to say.
Yeah, and I think there's a feature where you can even specifically say like only return like the IPs of this in this. So if I query like a DNS name for an NLB from a particular AZ, it'll only return the IPs for that particular AZ. Am I remembering that correctly?
Yep. I'm just posting that right now, the announcement in the chat. But yeah, it's usually done through DNS, so that we'll try to go and find it through, just as you said, to try to honor the AZ rules. And also it helps again with the routing. And you even have a diamond here, which is one of the most common things that folks will get into, especially when they start playing DNS tricks with network load balancer and having cross AZ turned on, as they start getting diamond routing situations, which could be a whole other issue. But
yep, exactly.
Is that something to do with diamonds are expensive and
yeah,
pay a lot of money?
yeah, well, very expensive, and also it's fun when your traffic doesn't go anywhere.
Right. Is this the equivalent of a modern day spanning tree loop or something?
Yeah. Oh my goodness. You just brought up a whole bunch of fears just in that one statement. Thank you.
You're welcome.
Yeah. Turn on spanning tree port fast everywhere. Anyway,
Jamie's not going to be able to sleep tonight. He's going to wake up broken out in sweat, like the spanning tree.
There's a whole story about auto manufacturing.
Status show the command is like show BPDU status or summary or something. I just remember like trolling through a 500 node network doing like show BPDU status, like what's going on? Oh my god.
2.5 square mile plant with a bunch of IDFs everywhere, all with port fast turned off and then on and then off again, and then everything is all wired in with a bunch of forklifts, and all went to hell, and I had to debug it. 24 hours of hell, man. Thanks. Thanks, Matt.
Well, and there is a question here on from Leo. He said, or they said, not a serious question, but when will we be getting rapid spanning tree support in AWS VPCs?
Leo, why do you hate me so much?
I just want to say one thing here, that we don't talk about roadmap on this session, on this show, but let's see what happens at reInvent this year.
Things are going to happen this year. It's gonna be fun.
Careful, Matt. You might be writing checks that you can't cash.
Yeah. We'll see.
Writing checks that Bezos can't cash.
I don't know if that's a thing.
Yeah, I don't think that's the thing.
Yeah, well, yeah, that's another question.
All right, cool. Yeah, so NAT gateways. Dominic, I think you were bringing this up earlier. So a lot of times, if you are sending, and this is one of those things, like, I'm going to go on a soapbox here and say, like, you should just be you should not send any traffic from an EC2 instance through a NAT gateway if you're going to S3 or DynamoDB. Like, don't do that. That's not a thing you should do. Reason for that being is you are going to incur that NAT gateway data processing. Whereas if you do something like a gateway endpoint, so we have two different types of endpoints. We have interface endpoints, and we have gateway endpoints. Gateway endpoints support DynamoDB, they support Amazon S3. If you create a gateway endpoint, rather than sending your data through a NAT gateway and having that cost per gigabyte incurred with that, you can just send it through this gateway endpoint. And the gateway endpoint, it's attached into the VPC, and there's no cost associated with that. There's no hourly cost, there's no data processing cost. Like, it's to the point where, like, if you go into the AWS console right now and you create a new VPC using like the create VPC wizard that, like, does all the subnets for you and the route tables and things like that, it'll throw in an S3 gateway endpoint for free. Like, you should just do that. Like, that is a thing that you should do. If you're not thinking about this and this VPC talks to S3, you should have a gateway endpoint. That's my
funny story in that one. When I was a generalist SA, that was one of the recommendations I made from one of my very first large customers. It saved him up to $55,000 a month. Mm-hmm. And the salesperson that was working with me is like, "What did you do? Our revenue just dropped." But that's what we do as SAs, right? TAMs, right?
Jamie, remind me to tell you sometime what my life is like when I roll in talking about network cost optimization and the glares I get from certain individuals.
Yeah. Like, that's our job, though. That's what we're customer advocates, right?
Absolutely. It is very funny, but it all works out. So you're probably thinking, all right, great. I have S3, I have DynamoDB, but I've got 170 other AWS services that I want to connect to. So what do I do with those? So for those, you could use interface endpoints instead. So again, instead of pumping it through a NAT gateway where there's that cost there, you could do interface endpoints instead. Now, the difference here with the interface endpoints is that they do have an hourly cost associated with them. So it's not quite the same as like a gateway endpoint. So there is an hourly cost associated with that. Like, it's not a whole lot, but there is a cost associated with that. And there is also data processing associated with it. So depending on, again, the amount of data that you're sending through this interface endpoint, that can start to, you'll see a cost incurred with that. But if you compare that with a NAT gateway, so like, let's take an example here again, probably blown out of proportion, but still worth thinking about, so this is US East 1, again, always use your pricing calculator. If you took 100 terabytes of data, throw that through a NAT gateway, it's going to come out to, around $4,500. You do that with the interface endpoints, even once you factor in, like in this example, I've got 2 AZs here, you could scale this up to add additional AZs, do the math on that. But in this example here, when you take that same amount of data, pass it through the interface endpoints, even once you factor in that hourly cost there, it's still way cheaper to do this. It saves you so much more versus sending it through a NAT gateway. And that's not to even talking about some of the other like benefits that you get with interface endpoints, like where you can do additional policies on the endpoints and attach security groups. Like, there's a lot of other things you can do with interface endpoints that make them much better for this than a NAT gateway.
Keep your traffic off the internet.
I love that you've convinced us to use interface endpoints, but you haven't even talked about the technical advantages. Right. And interface endpoints do have a great technical advantage in that they are private and, they're dropped inside the VPC.
They're 100 gig, they're super fast.
Yeah.
Secure, data.
That's what I'm saying. Like, all that, purely from a cost alone.
Yeah.
Purely from a cost perspective, they make sense. And yeah, so Matt, you're absolutely right. Like I'm not touching on any of the other stuff. Usually it's because I'm trying to make sure I'm like, finishing this in time, and I don't want to go off on a tangent here, but like, yeah, like there's absolutely a lot of other benefits there that make this worthwhile, even if you don't think about just the cost implications. All right, cool. Anything on that? I don't see any questions related to that, so I'm just going to keep rolling.
The only other thing I'll call out is using gateway endpoints inside of VPC, absolutely all day long. The only exception I tend to see, and maybe you guys can tell me if there's others, but the only exception I would tend to see when you should use an interface endpoint for S3, for example, is if you want to connect from on-premises via a VPN or a DX.
Yes.
Because gateway endpoints are only routable from within the VPC.
Absolutely. I've got an example of that later on where actually it talks a little bit about direct connect, but it also calls out, you need to use an interface endpoint if you're going to, reach through this from, an on-prem environment. Otherwise, you have to do something weird, like, throw like proxies in front of in a VPC so they can proxy it to the S3 gateway endpoint. Like, you don't want to do that at this point.
I always tell people when they ask, one of the main differences are why can you get to an interface endpoint versus a gateway endpoint. Gateway endpoints, remember, are routing change. It makes a change in the routing table to the VPC that is there, and that makes that VPC aware. But if you get an interface endpoint, it's like a virtual NIC that gets an IP address, and it has all the benefits that an IP address can do. Routability, reachability, all of that, as long as all of your firewalls and all of your routing and your route tables are all set to allow that to happen.
It actually, in the way that both of those mechanisms were built, it actually explains why there's a cost involved. Interface endpoints have a fleet there, and you're processing through EC2 instances as part of that fleet, whereas gateway endpoints are, like you said, just a routing mechanism, and there's no fleet there that costs dollars, so we don't have to charge data processing.
If we don't have to charge you, we won't.
Yep. Cool. Let's keep rolling.
Yeah, so there's a comment there too. It looks like from Leo on IPv6. Yeah, so if you're doing IPv6 through egress-only internet gateway, so that's not doing natting. So if you kind of building off of Matt's point there, where you have a fleet there and you're doing like some sort of like processing or happening there, that's why you wouldn't incur that cost with an egress-only internet gateway, because it's not actually like processing or changing the data in any way. It's just only allowing outbound data. It's not allowing you to connect, from the public internet back in.
There's a large portion of people too, and this is not a comment to Leo's question or statement, but a lot of people don't quite realize that IPv6 addresses, there are some that are private, but for the bulk of IPv6 addresses that you'll get in an operating environment, all of them are potentially public. They all have the ability to route. And that's the reason for an egress only, gateways, so that you don't get the return traffic that you don't want necessarily, because you're not announcing yourself. So IPv6, in and of its nature, being almost all of them being public, that are being consumed in corporations and in workloads everywhere across the world, affords you to not have to do a lot of those translations from an RFC 1918 address out to something that is routable, because that is all being exhausted.
Yep.
I'll shut up now.
No, you're good. You're good. This is
Keep
how
going.
this is supposed to go. We're just gonna keep rolling with this train.
If we do let Jamie keep going, he will consume the rest of the time. But
I mean,
you
that's
the
less time.
Kettle or the pot in this one here, Matt?
Hey, that's less time that I have to talk. Y'all can do whatever you want. Like, that's fine. So we're gonna come back to your favorite child here, Matt. So VPC to VPC, like this is, again, a lot of times when you're thinking about this, there's different ways to sort of reason about this, right? So transit gateway is probably the most common at this point. So with transit gateway, you've got an attachment hourly cost. You've got transit gateway data processing. So if you're going in this example from VPC A to VPC B, you're passing data through the transit gateway. Again, there's, as we've pointed out before, there's a whole fleet of things that are happening behind there. It's processing that data, passing it along. So there's data processing that's incurred there. Those are the costs for transit gateway. Now, if you take this and you extend it to another region, now we're starting to think a little bit bigger here. Now we're doing multiple regions here. And we do something like this. What we incur is we have the same, attachment hourly costs. Our data processing is going to be the same. But now, because we're crossing the regional boundary, we have the region out cost. And then there would be the region in associated with that as well, but there's no cost for the region in. It's just region out, source destination. And then from there, we go to our destination VPC in region 2. The other thing to keep in mind here is that when you're sending data across peered transit gateways, that cost is waived for peered transit gateways. So you're not going to get hit twice with that transit gateway data processing. So you'll effectively, for this flow, you still have to, contend with the cross-region cost, but the transit gateway data processing only is incurred once. And it's pretty similar with Cloud WAN too. So the biggest difference with Cloud WAN is that there is, so like if I go back to a transit gateway, for example, if I create a transit gateway in my account, I spin it up, I let it sit there, maybe I give it a name and call it my pet transit gateway. But if I don't attach anything to it and if I don't give it any data to process, it'll just kind of sit there and look at me. It's not going to cost me anything. With Cloud WAN, it's a little bit different where when you create a core network, you have to define where you want your core network edges, right? So that's where your core network can exist and where you can attach things into your core network. There is an hourly cost associated with that. And that's usually not a big deal. If you're coming from transit gateway and you're looking at like a multi-region approach, usually that's, not something that you're too concerned about, but that is something to think about as well, where there's that hourly cost associated with the core network edge. This has bitten me in like a lab account a couple of times where I like spin one up and then I forget about it and then come back later like, oh wait, I meant to get rid of that.
Much
but
like
otherwise,
the certificate that I've been trying to delete.
Is that what you've been doing this entire time?
Yeah.
Just like
If I look
quietly clicking in
distracted,
the
I'm
background,
like,
Yeah, that was Matt's concentration phase.
But otherwise, with Cloud WAN, a lot of the concepts are the same. You have an attachment cost per hour. You have data processing. The same notions are going to apply here. If you're crossing regions, there's going to be the region out cost and there's going to be the region in, but there's no additional data processing there for crossing the regions. So the biggest difference there is Cloud WAN does cost a little bit more, just in terms of at least for the attachments. I don't remember offhand for the data processing. Always check your pricing calculator. And then there's the hourly cost for the core network edges. And then we come to VPC peering, because people sleep on this one. So if you have a peering connection, so like let's look over on region 1 here. So if you have VPC A and VPC B, they're peered, and you're sending data from AZ1, in this case, to VPC B, same AZ, there's no cost associated with that. It's the same AZ data transfer. Now, if you're crossing AZs, again, remember you're crossing an AZ boundary, AZ out, AZ in, there is going to be a cost associated with that as well. And this is a great example of a case where if you have these VPCs and maybe they're part of, they're two VPCs that are very chatty and they're, separated for, whatever particular reason, but they have a lot of data that needs to go back and forth between them, you could peer them and avoid having the cost of a transit gateway or a Cloud WAN core network and have these VPCs still be, separate logical constructs, but eliminate a lot of potential cost of having them, being, communicating with each other by using something like a peering connection. And this also applies for cross-region too. So again, you could do a cross-region VPC peering connection. So if I have this VPC A that needs to talk to C, thank you Connections for making my day better. If we do that, you do still have to contend with, there we go, the region out cost, because again, you're crossing the regional boundary, but that's it. There's no additional cross AZ cost. There's no data processing cost there. VPC peering can be really powerful in this case, especially if you don't have a need for a transit gateway or a core network, if you're not doing any kind of inspection. Like if you imagine these VPCs all being part of the same security boundary and they're essentially trusted within each other, then you could use a peering connection, skip your firewall stack again, as long as your security team's cool with it. And then you can just move the data and just have to worry about cross-region. It can really be a big benefit. There was a customer, I have an example, I don't know if we'll get to it just with timing, but to kind of illustrate what that looks like.
I think one of the things that I have seen a lot with some of our large customers is this idea of an or between transit gateway and peering, when really it's an and.
Yep.
It's use both. If you've got a Kafka cluster sitting in another VPC, don't send traffic over a transit gateway. And the issue is actually compounded when you look at the application flow, in that it's not just one application in a VPC talking to another application in another VPC. It's, hey, I've got an application running here making multiple requests back and forth, and now you're doing that over a transit gateway 10 times, tiny bit of latency increase, but a lot of price increase if everything's running inside the same availability zone. And so peering is a great point solution to say, hey, let's just drop peering for this path, configure my routing appropriately, and now you're not going to be paying that data transfer charge.
What about throughput thresholds too, right, Matt?
Well, I love again that Dave's really diving into this and selling us on it just purely based on a cost perspective. If we talk about the technical aspects, with Transit Gateway, you've got a tiny bit of latency increase because you're going through a fleet. You've got to have that fleet to support the amount of traffic per availability zone. And so Transit Gateway is basically built in groups of fleets that are deployed supporting availability zones. When you're talking with peering, all we're doing is a hard swap on the VPC ID on the network adapter as the packet leaves an instance. And it's super cheap for us. So you can basically send as much as an instance can handle across a peering connection versus Transit Gateway. You're limited to, I think we upped it from 50 gig per AZ to 100 gig per AZ. But I really want to call out that 100 gig isn't a hard limit. It's something that we can work with you in. It's just how our fleet is initially scaled to that 100 gig limit. And you can send more. You can send 150, 200, 300. I have had some folks come back and say, we didn't use Transit Gateway because we wanted to send 150 gig. You can, but you got to talk to us. But yeah, there's a whole bunch of technical things we can dig into around that, but that's not why we're here today. So
yeah, exactly. I just knew that was going to get you off because that's one of the things you like to talk about.
I'll consume the rest of the time we have on our stream today, but I think we've got better things to talk about. So let's keep going.
No, but this is good. And that's always one of the things, right? So like, again, we're just talking about cost optimization, but cost does not exist in a void. Think about we have this whole notion of like the AWS well-architected principles, right? So there's security, resiliency, availability, performance, the rest of those. Yeah.
All of them.
But you know what I'm talking about, like
accountability. I think that's one. That's not one.
Sustainability, I think, is one of the newer ones. Yeah. But like all of these things like fit together. And so even there's some cases where optimizing for cost also gives you some additional benefits, and like these can be one of them. And then there's going to be some cases where like maybe you have to make some trade-offs, so like to use this example here, if these VPCs weren't in the same security boundary, or if you had a mandate that you needed to have inspection between them, like this wouldn't necessarily work because you'd be optimizing for costs, but you'd potentially be taking a step backwards in terms of like what your security requirements are, and treating them as you needing to filter between these boundaries. Okay, get off my soapbox. So centralization. This is another thing that comes up, is like, should I centralize? Should I not centralize? So like, here's an example, right? Let's say you have a VPC. We've got, NAT gateways in each VPC. We start adding more VPCs. So that means more NAT gateways, more NAT gateways, more NAT gateways. We're NAT gateways everywhere. Look under your seat. What do you get? You get a NAT gateway, right? If you take a scenario like this, where you've got a terabyte of data egress per month, it comes out to around 12 terabytes a year. That's 100 VPCs. You have, in each of these VPCs, you're incurring the hourly costs in the NAT gateway, as well as the IPv4 address costs, with that. And now, so if you do all the math on that, that comes out to around 88,000 just for the hourly costs per year. I'm not even talking about data processing here. This is just the hourly costs, right? Now let's take that same example and let's plug it into a transit gateway. So if you do that, now let's say we've got multiple VPCs here. We've got our transit gateway. We have a designated egress VPC, and that's where our NAT gateways are going to be, right? Now we have to factor in the transit gateway data processing costs as part of this new, sort of new scenario here, because that's what's different here. But now we only have a pair of NAT gateways and a pair of public IPv4 addresses associated with them. So once we factor that in, the NAT gateway hourly cost per year plummet to not a whole heck of a lot. And even once you factor in the transit gateway data processing cost, again, in this scenario, it works out super well. And that's just, now you'll notice I'm not showing the NAT gateway data processing cost, because that's going to be identical across both these scenarios. It doesn't matter whether I take a terabyte and send it through, one NAT gateway, or if I send it across, like a dozen NAT gateways, it's, it's bytes, right? So whether it's all in one spot or across multiple, that doesn't matter. But this is an example of where it makes sense. Like, oh yeah, you should think about centralizing this. If you have resources that you have a lot of them, but you're not making like very heavy use of them, that can really be a great example for centralization. And even if you take this and you expand it, right? So move this up to 100 terabytes, same thing. So from our hourly cost, there's no change there, again, because it doesn't really matter how much data you're passing through. Now it does matter when we do with centralization, because we have to start thinking about our transit gateway data processing. So now we've bumped this up to around 24,000. So it still works out in our favor, but it's starting to get more expensive. And if I go even further than that, now all of a sudden we're going to see that it doesn't make sense to centralize in this particular way anymore. And there might be alternatives to think about instead, because now we've just added so much more for the transit gateway data processing that this doesn't really make sense. So it might make an alternative might be, maybe you split the difference where you have some NAT gateways in one place. Do these VPCs need to have internet access? Do they need to have internet egress? There's different ways that you can approach that, but the point I want to make here is that as you start to scale things up, it can make sense to centralize versus taking sort of a distributed approach. And this is just with NAT gateways. You can also do this with like private link endpoints. There's a great reInvent talk, I think it was from like 2020, that talks about like private link endpoints and whether to centralize or to distribute them. I think Laura Caicedo was the essay who delivered that. And so if you can find that one, if you can put it in the chat, Matt or Jamie, that's a good one to reference. I reference that pretty regularly. But that also kind of illustrates, when to centralize, when to not centralize, and talking about it from the perspective of like private link endpoints.
I think that the numbers here are fascinating. And we see an effect on how customers are deploying their VPCs and their architectures. And there's this kind of story of going from 1 to 10 to 30 to 300 to 3,000 VPCs, and then back to 1. And this is like with the deployment size on AWS. Some of our hyperscale customers say, hey, I have a team of folks that can manage stuff. I just want one VPC. Like, AWS, get out of the way. I'm going to do everything in this one VPC. And it's potentially because of things like this. But there is this sweet spot, and it's at 88K, depending on the numbers here, of where it makes sense to say, hey, instead of in every VPC, we're going to have a central VPC, and the management overhead is so much less because I don't have so many more endpoints. And I think there's a fascinating life of a customer story here that maybe we could tell one day, going from 1 to many VPCs to 1 to many NAT gateways to 1 and back again. I don't know.
Yeah.
It would be interesting to see how long the sweet spot lives for, depending on the growth. I'm sorry, Dave, I cut you off.
No, and the thing is too, I'm only turning one knob here, right? We've got 3 potential knobs here. We've got the number of VPCs, we've got the number of availability zones, right? Because if we have more AZs, that's more hourly costs there. And I'm only turning one knob, which is just the amount of data. Like this will start to morph depending upon the number of things, and I think that like private link endpoints are another great example where you start to see that, where it's the number of like services that you're using for private link, for example, can also have an effect on the number of like endpoints that you're using, and then whether it makes sense to centralize them or to distribute them.
So Nick has a question here. Are the NAT gateways required because of the private subnets?
So if the subnets are private subnets, then they necessarily, a private subnet in this case it doesn't have a route to an internet gateway, and typically those resources don't have IPv4, public addresses associated with them, right? So like you could have a private subnet or a subnet that has no route to the internet and still have I think you can still have an IPv4 address associated with it. You just can't reach it, because it's functionally not that subnet. So if you had resources in a subnet that you don't want to communicate out, or you don't want to be able to receive traffic in from the internet, but they need to be able to reach out for, package updates, software updates, things like that, that's where the NAT gateway would come in. Otherwise, you would need to have a route to an internet gateway, or you need a route to an internet gateway, and you would also need an IPv4 address or a public IP address associated with that.
I think we're assuming in this case that these instances want to talk to the internet, and we're not building direct two-way communication for the instances. And I think your architecture is always going to depend on the initiated direction of traffic. In this case, you've got instances that are saying, hey, I want to talk to the internet. If you had instances on, or if you had someone on the outside saying, I want to talk to that service, then you'd probably front end this with a network load balancer or an application load balancer. So your architecture does depend on directionality.
Yeah, that's a good call. Yeah, I've kept this very deliberately condensed just for the sake of, illustration. But yeah, this is assuming in this case that you've got resources here that are in a private subnet somewhere, and the NAT gateway needs to live in this public subnet so it can actually route traffic out to the internet. So that's why it's using that public subnet green, I guess. That's how we typically think about things, right?
I think we don't know the numbers, so maybe we could look into some of our data on customers that we've spoken to about this, but the central egress VPC is probably today one of the most popular topics of discussion when we talk to customers from a networking perspective. Customers get to a point where they're looking at this and saying, hey, how do I simplify? How do I centralize? How do I reduce costs? And that central egress security VPC, could be security or not, is definitely one of the tools there. We haven't layered in gateway load balancer or firewalls, which might change things again. I have seen in some cases, and I'm trying to remember exactly how the math worked out. We could probably maybe draw it out another time, but using firewalls and other things in the central VPC, I think it was more expensive at a certain point in that case to do a central VPC. But when we spoke to customers about it, they were like, I really like the simplification of it though. I don't want to have to manage firewalls in every single other VPC. I want to manage a fleet inside a central VPC, right? So I think outside of the cost even.
Yeah. Not to mention that. I was going to say, not to mention dragging data back and forth. Like when you're centralizing, just as you were pointing out, dragging data across transit gateway, right? 2 cents per gig out, going the same amount of data back and forth all the time. Now you're effectively doubling the cost.
Yep. Yeah, and that also starts to then get into an operational understanding. So some folks they're used to their on-prem environment, or they're used to the world where they had their firewall, and that was the edge of the world, and beyond that was here there be dragons, right? And you want that kind of same approach to be able to reason about that and just think about it in a centralized way versus I've got firewalls here, am I managing them through firewall manager, through a policy, that type of thing, which could just be a little bit of a different philosophical type of approach, or just a different way of thinking about it that some folks just aren't comfortable with, and that's fine. There's any number of ways to do things. Okay. Speaking of which,
I think we're running a pot here on how many times I can steal your thunder in the slides, or cue. I won't say steal your thunder. I'll say cue you up for the discussion.
This is actually very personally validating for me, Matt, because honestly, coming into this, I'm I hope did I cover everything? But Matt just oh yeah, and what about this? I'm I got you. Oh yeah, what about this? Oh, I thought of that. Yes, all right, I'm good. Thank you. This is a very affirming experience for me, Matt.
Great. I'm glad to help.
Cool. So I know how are we doing on time?
Because 11 minutes.
What's that?
11 minutes.
Let's say 10 minutes.
Okay. So I'll burn through this quickly then, because I don't want to linger too long here. But again, so if you're talking about a centralized inspection here, so what that looks like, again, the transit gateway costs, whether or not you think about those as part of a centralized inspection, most of the time you're still going to have a transit gateway anyway. So when you're thinking about this, you might not always consider the attachment cost part of the cost of centralized inspection, but I included it here for completeness, just for the sake of visibility. So if you're sending data from VPC A to VPC B, and you're going through an inspection stack, you're going to hit the transit gateway. There's data processing there. We know from looking at it earlier that the gateway load balancer endpoints have an hourly cost. They have data processing there. The gateway load balancer itself has load balancer capacity units, just like an ALB, just like an NLB, similar dimensions there. Goes to your appliance. There's also an hourly cost associated with the gateway load balancer, again, because it's ready to accept traffic. We're passing it back through that endpoint again, and now we're hitting through the transit gateway again. So those costs will start to add up, again, because as we're going through multiple different layers here, multiple different things are processing our data, and it's passing through multiple different points there. Now, if you do something like egress, to Matt's point earlier, costs are going to be largely the same until you get to your appliance there. We're going to go back through our gateway load balancer endpoint. But now we're going to pass our traffic through a NAT gateway. And the NAT gateway, we all know this, it's got that hourly cost, it's got the data processing, got the public IPv4, and then there's the internet data transfer out. So there's a lot of like data points here. And I'm not showing like, an individual cost per use pricing calculator. But this is all something to think about as you're deciding like, okay, we want to do centralized, inspection and egress. All of these points you just need to think about. And a lot of these are going to be like how much of that is based off of like the volume of data you're sending through. So that can be a little hard to think about, but it is worth noting that you have to make sure you have an understanding of here. I ran into a customer who set this up and didn't have any notion of what these costs were. And they just started throwing everything at it. And then they were surprised when they, at the end of the month, their networking bill was higher than they expected. And they were trying to understand why. And they hadn't really thought about all of these different, components that were in the path here from, a VPC out to the internet. I'm going to rip through network firewall as well. It's going to be very similar. Again, we have transit gateway data processing. That's usually the biggest thing that comes up here. Network firewall endpoints have an hourly cost associated with them. They do have data processing associated with them as well. And if we're sending this to spoke VPC B, so we're just going A to B, we're going back through the network firewall, and then we're hitting the transit gateway again, and there's additional cost there. If we're doing egress, this was something we alluded to, or I think we called it out earlier. But with this, when you have a NAT gateway and a network firewall endpoint, so the firewall endpoint has an hourly cost. For every hour that network firewall endpoint's running, and the NAT gateway is running, that NAT gateway cost is waived. Same thing for the data processing, where the network firewall data processing essentially is you're covering the cost of the NAT gateway as well. That data processing cost is covered, and you don't have to think about that. So it's just something that is available if you're using network firewall with the NAT gateway there. Everything else remains the same with the public IPv4 and the internet data transfer out. So I could talk a little bit about IPv6. I don't know if I have enough time to do that, or I could show you real quickly this networking cost calculator demo that's available. So I'll throw this out to folks in the chat. What do you want to see? Do you want me to talk about IPv6 for a hot second, or do you want me to show you a quick demo?
We'll cue the music.
I'm going to vote the demo, I think.
I'm going to vote the demo too.
Yeah.
All right,
go. Nick,
there you go.
Yep.
Nick, Nick has saved the day there. All right. So I'm going to share this.
Oh,
here.
It's unanimous, I think. Yeah.
It's unanimous.
Brilliant. All right. So let me zoom in a little bit just to make this easier for you all to see. Now, I think we shared this link earlier already, but if we didn't, Jamie or Matt, if you could put this in the chat. This is a blog post that was launched, earlier in September. What this is an open source thing that you can deploy in your own environment that is essentially a networking cost calculator. It uses CDK to deploy everything. So, you'll need to have the right permissions to make sure you can actually deploy this. But what this is, it's a tool that you can use in addition to the pricing calculator to, get you some additional info about, what things look like. So I've gone ahead and deployed it. So here's an example of what it looks like, right? So let's say I want to show a transit gateway here, right? So this is going to show me my data processing costs associated with this, right? And I can adjust, the number of transit gateway attachments. It'll give me hourly cost, monthly cost. I can add in other costs as well. So let's see if I plug that in here. It'll show me what that comes out to for 3 attachments. It comes out to, 6 cents per. All well and good. But I can also do some things where, like, if we do, gateway load balancer in a centralized approach, right? So now I can see that I've got my 2 cents per gigabyte to the transit gateway, and then hitting my gateway load balancer endpoints, and then all of that stuff there. So this is only showing a couple of things. Now, it's worth noting, it's kind of still like a work in progress, right? So if this is something that you find valuable to be able to like click this and plug into it, let us know. The blog post has a link to the GitHub repository. Let me see if I can scroll down and find that. Here we go. Pop that open in a new tab. And if you're particularly adept at coding, and you want to take a swing at this, you can add things into this as well. So if you notice any like inaccuracies, or if there's things that you want to look at, or if you wanted to add additional scenarios or propose additional scenarios, you open an issue, open a pull request. This would be something that you could look at and add, functionality to as well. So again, this is going to show like a centralized. You could do centralized with VPC endpoints. We didn't look at that as part of this discussion, but that would be something to think about as well. And it's just another tool that you can use to think about networking costs and kind of just like prompting like, okay, well, what are the costs there? What are the implications? What are the components in the path if I decide to do this? And how would I think about that?
I have a feature request, but it's a bit of a pipe dream. I would love to be able to do a describe command on my account and
Yes, I was
then
going to go there.
import it into this, or even like you don't know, who cares about the mechanism, but what about if this was like, this is your architecture running today, and this is how much you're paying for it. Like that would
And
be
even being
amazing.
able to like up and, say, okay, what happens if my traffic doubles?
Mm-hmm.
Well, I mean,
Because think about it,
some
Black Fridays and all that whole scenario, MRP
Like a
goals,
modeling type of approach. Yep.
Yeah.
there's actually some internal ideas that we had a long time ago, and they're hard problems to solve. And it would be amazing to take this and show your architecture and then use it as a capacity planning tool to say, this is how much traffic I'm sending right now, and this is what it looks like from a projected perspective to say at these different points, and this is what your flow looks like. And I'll come back to one of the main things that Jamie, you've heard me talk about this so many times, but one of the main things I tell customers when they're like, hey, what should we do with our architecture? And I say, the first thing, understand your traffic flows.
Understand your flows.
Communications from A to B to C to D, who's talking to who. Once you've got that, then you say, well, what's it going through? A transit gateway or peering or to the internet, and now you've got your kind of base level understanding of connectivity, and you can kind of go from there. So the flows are so important, and this is amazing in that you can be like, all right, well, let's just kind of build a sample here. What are we going through? Gateway load balancer, transit gateway, VPC, et cetera, et cetera. Very cool.
Right. Matt, you did that thing again. So let's do this. Can you stop sharing my screen for a second? I'm going to flip to the end. So, because we've got about 3 minutes left, I think. So
3 minutes.
3 minutes.
All right. Let me skip to the moral of the story here. And yeah, sorry, Alex, about the IPv6, but hopefully she doesn't see it.
We can talk about IPv6 another time. It's important, but
it is important. And we care.
All right.
We do care.
All right. Yeah. If you want to start sharing again, let me know when that's up.
And just for reference, I haven't seen your content or slide deck or anything before we chatted this morning. So
you have not. This is true.
You're not paying me to talk about this stuff.
I mean, if I were, that'd be pretty cool.
That's all a lie. I sent it to him earlier. We downloaded your blog and Reddit.
Well, that's not my blog post. I should call that out too. I have nothing to do with that. I just thought it was a really neat solution, so that's why I wanted to call it out. But yeah, so the key takeaways here: know your flows. Like that's exactly what you all are talking about. That's the moral of the story here.
Yeah.
Like, what boundaries are you crossing? What services are processing data? Again, think about. I keep mentioning boundaries. Think about that from a data transfer cost. If you don't have an understanding of what those are, like that can sometimes come down to a question of you need to actually like talk with the application team that's like designed this, like, well, what are you actually doing? Because they may not know sometimes. Like they're just like, well, I set it up, and okay, well, what does that actually mean? Like, know what's happening there. And because once you know those flows, you can think about them at scale, right? So like we saw some examples where you start small and then you start more and more data, the bigger you pass it through. Maybe it doesn't make sense anymore, right? And cost is not the only dimension. I mentioned the well-architected framework earlier. There's other components that you need to think about there. And what are the trade-offs, if any, when you do cost optimization? Can you do it in a way that you're not, compromising something else? Or if there are trade-offs, are those acceptable trade-offs for, your particular organization? And then finally, context matters. So I gave the example earlier of like those two VPCs that were, directly peered versus, going through something like a transit gateway or a Cloud9 core network. If you have scenarios like that where you don't actually need to have traffic inspection happening between VPCs, then that's important to know. That's a conversation to have, like, hey, do we actually need to have this inspection happening here? Do we need this additional data processing to happen here? If not, if these are all part of the same, security boundary, great. Let's peer them. Like that's a great example of that I think is important to call out there.
All right. Well, we are at the top of our.
Cool.
Dave, we're going to have you back. That's the one key takeaway from this whole thing that is not listed on this bullet point. We need to have you back because there's a lot more nuance and such. This session will be recorded. It is going to be on theroutingloop.net. So give it to your friends if you need to. I'll put it up a little bit later. And thank you again, everybody, for showing up, and Dave for you, and of course Matt for being a mind reader as always. So
these are great topics that we don't talk about
great.
enough about, right? This was an awesome session. Thanks so much, Dave.
It was a pleasure being here. Thanks, everyone. And yes, IPv6 to be continued.
To be continued. And we're out.